Verification required, never mind. All right, let's do attendance. We have Aki, it's not here. Blount, not here. Boggs is here. Bonner is online. Clay is not here. Clayton, not here. Dawson's not here. Ellis, not here. Paula's not here. Green is here. And in red. Harrison is here and in red. Henson is here and in red. James is here. Esterson's here and in red. King is online. For your online people, I'll remind you, you have to send the words to get the credit. So I see that you're online, that's awesome. But you have to get the words. It's more important for online people, because if you're like me, it's easy to get online in the meeting and just your brain starts going somewhere else, like to your phone or to your TV, whatever it may be. Anyway, Lewis is not here. Lindeque will not be here. Morrison is here. Grace, first name or last name. Mitoma is not here. Rice is not here. Ward is here in red. Good morning. Wilcox is here and in red. Wilder. No, that's Paula. Wilder is not here. Parks, saw her attempting to get online. Hopefully she made it. And Paula is here. Did I miss anybody? All right, please bear with me while I pull up this PowerPoint. Once again, sorry for the late start. Good morning.
Good morning.
Ellis? This thing. So, Ellis is here. So the first word for attendance will be PowerPoint, since I'm fighting with the PowerPoint right now. That is where we left off. Okay. Very good. I didn't mean to hit that button for those of you online. There we go. Now we're finally up and at it. All right. Let's get started with the lecture. I'll close the door. One last friendly reminder. Maybe the last reminder at all. I'm here to help. I really am. I'm not just saying that to say that. Anytime you need to work on an assignment, or maybe you already think you're done with an assignment, like I'm going to submit this, feel free to send me an email. Like, hey, can you meet me online really quick and look this over? And I'll look it over and be like, yeah, make sure you do this. Don't forget that. Let me help you. I appreciate that, because a lot of people are missing some attention to details, and it's easy to do. I know you guys got a lot going on. Like, for example, this week's pre-lab, or next week's pre-lab, the one for the biochem, or biological molecules, you'd have another video to watch. I made it bold, I highlighted it. I was hoping everybody would see it. It's been missed again. Also, if you scroll down, there's 4 sets of hypothesis questions. So if you look at the last question, it says, make sure you answer all the hypothesis questions. So scroll down and answer them all. And a reminder, regardless of if it says to do that, you should read a whole lab before you come to lab, right? So if you're reading it and paying attention, there's no way you could have missed that. So read the whole lab, make sure you're paying attention. I know it's a lot. I know this isn't your only class. So come to me for help. Especially online is best for a situation like that, because I can share your screen. I can share my screen. You can share your screen. I can help you. All right. Any questions about the class before we start talking about this again? All right. So here we go. Big picture. What we're talking about right now is biological molecules. We told you that the 4 categories of biological molecules in any particular order are carbohydrates, lipids, proteins, and nucleic acids. The first one we started talking about was this. We're talking about carbohydrates. And what we left off saying is that in animals, that's the primary energy source, and in plants, it is too, but also for both, they also play roles in building other molecules. But I think probably the most important thing from that last slide that we talked about was this right here. Probably the first bullet point. Right there, right? And also, I pointed out too that this bullet point should also be here, right? It's energy for both, but we'll actually get back to this because it's not just carbohydrates in general that do these things, but there's specific types of carbohydrates that you're going to need to know about. So let's focus on that. We'll skip past this and focus on that. First one we need to talk about is monosaccharides. So again, we're talking about 4 large categories of biological molecules. One of those 4 is called carbohydrates, and now I'm telling you there's subcategories of that, right? And I'll go ahead, I won't jump the gun. So let's just say monosaccharides is a type of carbohydrates, right? That's one of the types you're going to need to know about. And like I said on Wednesday, it's a good time to remind you, a lot of what this exam is going to be about is like I'll give you a question and I'll explain something or give you an example, and you'll have to recognize from the example, am I talking about carbohydrates or lipids or whatever, right? So a part of understanding that or figuring that out is what are the monomers, right? What are the polymers? So here we go. This is the first time I'm telling you this. The monomers of a carbohydrate are monosaccharides. So you need to know that. If you take notes, that's something you should definitely write down. The monomer of carbohydrates are called monosaccharides. That one's kind of easy because they both have the prefix mono. If that was all I was teaching you, that would be easy. But you'll see later when I start teaching you some of the other monomers, it gets a little bit more complicated. But yes, monosaccharides are the monomers of carbohydrates. You need to know that. What that means is they cannot be broken down into smaller sugars. So you can break them down chemically, but once you break them down, they're no longer considered sugars, right? So this is as small as a sugar gets, and there's different types of them, as you're about to teach you. Usually they end with the word ose. I'm definitely not going to test you on that, but that could be useful, right? So if I give you the name of something and say, hey, what kind of biological molecule is this? You know, like I said, the exam will consist of me giving you an example and you telling me what kind of molecule it is. So again, I'm not going to ask you if it ends with an ose, but that'll be a hint, right? If it ends with an ose, you should think, all right, that very well could be a monosaccharide, which is a carbohydrate. Likewise, I'm definitely not going to ask you this, but your book talks about it, so will I. They are categorized, these monosaccharides are categorized by the number of carbons. So if there's 3 carbons, it's triose. 5 carbons, pentose. 6 carbons, like the one you drew for lab this week, hexoses, right? So hexose would be like glucose. Anyway, once again, I want to make sure this is very clear. If you take notes, you don't need to know this. I'm not going to ask you about the different number of carbons, but your book talked about it. So I wanted to tell you about it so you knew when you're studying your book for the exam that that's something I'm not going to ask you, at least for the exam. I honestly don't even remember if I have it on the quiz or not. It's a good time to remind you that you can use the quiz as your study guides for the exams. Obviously, not every single question that you see on a quiz will be on the exam, because I narrowed it down, but all the questions that you see on your exam, for the most part, have come from the quiz. Anyway, some common examples. Another great thing I'm going to put an X through. I'm not going to ask you this. Some common examples of monosaccharides include glucose in sports drinks, fructose in fruit. Where this goes, that's kind of in the way. Anyway, and also honey, or both of which can be found in honey, right? Glucose and fructose can both be found in honey. Again, those are just examples. Let's talk about some independent work ideas if you want to write about it. This isn't one where you're going to send me an email with a quick answer. This would be a paper. Like, what are some examples of trioses? What are some examples of pentoses? What are some examples of hexoses? What are some other common examples of monosaccharides other than sports drinks, fruit, and honey? Just throwing that out there if you want to write a paper. Any questions about this slide before I show you a picture of some of the stuff that's in honey? Okay. These are the 2 that I'm talking about that are in honey, glucose and fructose. You do not need to know the 2 different types of monosaccharides that are in honey. But this is important, even though it's not from your textbook, because I'm now introducing you to a new word that you do need to know. Isomer. You need to know what an isomer is. These are two molecules that have the same chemical formula, in this case, C6H12O6 for both of them, but a different arrangement. And I'm going to pretend like I did this timing on purpose, because this is really perfect timing. Because the lab you did, you had to draw all different stuff, right? And if you were to all compare notes, and so what you drew for C6H12O6, I guarantee you we would have a lot of different versions of what it looks like, a lot of different correct versions, because you can draw them different ways, right? This meets all the rules. We got the four, each one of those carbons has 4 bonds. Each one of these oxygens has 2 bonds. This carbon also has 4 bonds, right? But it's a different shape, right? Slightly different shape. And as you might remember from what I was saying last time we talked, having a slight, let me back up. They have similar shapes, right? Very similar shapes, which means they have very similar functions, which is why, for example, they both taste sweet to us. However, they are slightly different, right? Slightly different shape, which means they have a slightly different function, because one of them is actually sweeter than the other. Not that you need to know that, but the point here is, again, this whole form and function thing, right? The shape of something matters. And also the other big thing here is you need to know an isomer is. Same formula, different arrangement. Also, does anybody remember the only other word I've taught you so far that has iso at the beginning? Or have I? What do you think?
Isotope?
Yes, thank you. You remembered it quicker than I did, and I'm the one who taught it to you. Yes, isotope. Do you remember what it is? And if you send the words for extra credit, remind me that you answered that question.
A positive hydrogen?
I like it, because that would be a slight example. So an isotope, if you remember, it's an atom, right, of an element that has the same number of protons, obviously, because that's what defines it as an element, but different number of neutrons. So generally speaking, in this class, when you have anything with a prefix of iso, you should think, okay, same something, but different something, right? So for the isotope, same number of protons, different number of neutrons. For isomers, same chemical formula, different arrangement. And if I remember correct, this is only one more iso thing that I'm going to teach you this semester. But anyway, any questions about the side before we move forward? The second word for attendance will be honey. And if you're watching the video, not the live stream, I'll get you in a second, but not if you're here live right now streaming, but if you're watching the video, instead of sending the words, or instead of sending me just the word honey, do a Google search, send me a picture of a person named Honey. Nickname, real name, I don't care. Anyway, notice there's no questions about that as we move forward. All right, glucose and fructose again. This is everything I just said, but now it's in writing for you. Glucose and fructose are called isomers. Isomers are molecules that have the same molecular formula or chemical formula, however you want to say it, but different structures. And again, I already asked you if you had any questions about that. You didn't, so we're going to move forward. Here's a great example of isomers. I don't know if I learned this on Breaking Bad or if I saw this on Breaking Bad and was like, oh yeah, I remember that. But Breaking Bad's pretty old now, and so am I. Anyway, and that's also a big hint. Does anybody know what one of those two chemicals are, or excuse me, molecules? I don't expect you to. But before I even tell you, you can look and see they're very close, right? Don't those things look almost identical? They're like mirror images of each other. But one's used for making meth, and one's used for making things like Vicks VapoRub, right? One's useful. Some might argue they're both useful depending on how you use it, but one's a drug, and the other one, or excuse me, one's an illegal drug, and the other one is used for over-the-counter medicine. And that's a great example. And I want to say again, I'll say this a few times throughout the semester. There's a big thing that I like to call chemophobia, where people try to scare you by using chemistry. And they'll be like, especially with food, like, they're feeding you this, and it has this molecule in it, and this molecule in it is only one carbon away from being this other scary molecule. And it might be true. But think about this. This has the same exact chemical formula. It even has the same shape, except it's a mirror image of itself. And one of them is used to make meth, and the other one's good for it, useful for it. So again, when people try to scare you with something with ingredients, keep that in mind. And they do it all the time. I have a feeling most people, at least on social media on my newsfeed. I have a friend, I can't speak today. I have a feeling most of my friends aren't deliberately misleading people. I think they've been misled and they're just trying to help people. Like, oh my God, this is only one carbon away from being a plastic. Yeah, no, never mind. We'll get on that soapbox. So don't be scared. Don't be fooled. Isomers are important for that reason, amongst other reasons. Anyway, monosaccharides, particularly glucose, are the main fuels for cellular work. I might or might not ask you that. But like I said in the very first slide when we were talking about carbohydrates, remember I was telling you that that's the primary energy source for animals? Well, there you go. It is. Especially glucose, right? And you're going to be very familiar with this starting, not this exam, but the next exam, the next module. We really get into something called cellular respiration, where we make energy. Well, that's a bad way of saying it. We make energy useful to us, and we use glucose to do that. Anyway, another thing, and I'm not going to teach you this, but this might be helpful if you really think hard about some of the other stuff I teach you, then this question would pop up. I'm not even going to bring it up because I don't want to confuse you, but just so you know, not that you need to know, but when you put monosaccharides in water, a lot of them form rings. So remember the drawing that I just showed you of glucose? It's just like a big straight line, right? There's a bunch of carbons, right? Actually, the glucose and the fructose. It's basically a straight line, right? You had some things sticking off of it. But for the most part, it was just straight lines. But what I'm saying is that when you put something like that in water, they do form rings. As far as you're concerned, as far as the exam is concerned, that's completely useless knowledge. But again, if you really dig into things and think about things, if I didn't teach you this, that might confuse you. So again, I'm not going to dig too deep and confuse you, because if you haven't thought this confusing thought, I don't want to put it in your head. But we do have one student in here who loves to ask questions, and I love it. I can tell she's thinking, so I can picture her needing this information, and I'll just leave it at that. But yes, they do form rings when they get wet. Any questions about that? All right, so we are now done talking about monosaccharides, which is one type of carbohydrate. Now we're going to talk about another type of saccharide. If we're done talking about monosaccharides, any guess what the next type of saccharide we might talk about is? I don't expect anybody to know this, but you could pick up some hints here. Good. That will be a next one, yeah, but not the next one. So that's great. Yes, we will talk about polysaccharides, but we're talking about monosaccharides right now and polysaccharides later. Any guesses what we might talk about next? That's okay. Disaccharides. So mono means one, di means two. Disaccharides are just double sugars. So all those monosaccharides I told you about, which again are monomers, you put two of those monomers together, you get a disaccharide, because 1 + 1 = 2. I may or may not ask you examples. Again, this exam will be a lot of me providing you with an example and you recognizing that example as something else. Let me get specific. What I mean by that is I won't say sucrose is what. Right? There won't be a question where I say, what is sucrose? And there's not going to be a question where I say, name all the examples of disaccharides that I told you. Right? There won't be questions like that. But I might say, here's this thing called sucrose, and I'll give you some other things that'll give you some hints. And yes, the name is one of the hints of what kind of molecule it is, right? So again, you don't necessarily need to memorize that sucrose is a disaccharide, but that's one of the hints that'll help you figure that out in the exam. Does that make sense? Not any one particular thing that you need to memorize. Just all these things together are all hints to help you figure out this particular type of biological molecule that you get on the exam. So any questions about this slide? We'll still talk about it. One thing you definitely don't need to know, though, is this. The formula. I mean, I've not even taught you that type of drawing, so those drawings are probably useless to you. But again, like I keep saying about chemistry, you don't need to be a chemist to see that things have a shape, and shapes fit together different ways, right? They should fit together like puzzle pieces. So just knowing that they have very similar shapes means they're very similar in what they do, but also since there's slight variations in their shapes, there's slight variations in what they do. If you download the PowerPoint, you can watch this animation of this monosaccharide coming together with this monosaccharide to make a disaccharide. And here's a review for you. I don't expect you to remember it yet, but I have taught you this. When those two things come together, what kind of reaction is that? There's only, the way I taught it, there's only one or two answers. This is a multiple choice question with only two correct choices. And I give you a hint. When they come together, it produces a water molecule. We have taken a water molecule out of the reactants. We've removed the water molecule. Yes, good. He's from South Florida. He knows all about dehydration. It gets hot and muggy down there. Of course, that's a different type of dehydration. But anyway, yes. When you bring them together, that is called a dehydration reaction. And again, I'm certainly not going to ask you what lactose is, right? I'm not going to say, what is lactose made up of? Which is glucose and lactose. I'm not going to ask that. But again, for the exam, I might describe lactose. And more than just the name, I might give you some other information. And again, you would need to use all that information to say, oh yeah, that is a disaccharide. And a disaccharide is a carbohydrate. So any questions about that side? All right. So based off of what I just said, let's expand on it some more. Some more things you don't need to know. Lactose you can find in milk. Maltose you can find in beer. I might study some maltose tonight. It is a Friday. Malted milkshakes. Malted milk wall candy, I think that's from your old textbook. I think those are called Whoppers, but I don't think your book wanted to use a brand name. Maybe they didn't get paid. And of course, there's sucrose and table sugar. So that's important, not for the exam, but just so you know, the word sugar is used a lot. But generally speaking, when people say sugar, this is what they're talking about, right? When someone says, hey, I need some sugar for this recipe, they're almost always talking about sucrose. But again, these are just examples. Might be good independent work topics, right? Where else can we find lactose? Where else can we find maltose? Where else can we find sucrose? I mean, you could just, a million questions you could think of from this. How many calories is one molecule of lactose? How many calories for maltose? How many calories for sucrose? Is one healthier than the other? Is one sweeter than the other? Does one last longer than the other? I don't know. I mean, there's a bunch of things I don't even know. So most likely, if you were to dig into that for independent work, you might teach me something. Which is why I love for you to, one of the reasons why I love for you to share your sources. Because I also would like to read and learn something. Anyway, any questions about those examples that will not be on the exam? The next word for attendance is beer. If you're watching the video, not the live stream, but if you're watching this video at a later date, don't just send me the word beer. Send me a picture of a beer. And if you have a favorite, obviously if you're old enough to drink, I'm not condoning underage drinking, send me a picture of your favorite beer. Extra credit if you send me a 12-pack of beer. I'm just kidding, that was recorded, so that is a joke. I'll never give you extra credit for that. Actually, I won't even accept it. Anyway. Really quickly, this is not your textbook, so I'm only going to really talk about this quickly. As far as the exam is concerned, this is pretty useless. But as far as your life is concerned, this is very useful because it's ubiquitous, it's everywhere. Again, sucrose is the main carbohydrate that you can find in plant sap, right? This is where we get sugar from. That's why maple syrup is sweet. And you might not think of like the table sugar that you're cooking with as plant sap, but that's where it came from, right? Either sugar beets, probably, sugar cane. It's not like they just take the sugar cane and shake it and sugar falls out. No, they take the liquid out of it, which is the sap, and they do some stuff to it, and then we get sugar. But then there's something else, something called high fructose corn syrup. I'm sure you've heard about it. It's made by a commercial process that converts glucose to the much sweeter fructose. I'm not going to ask you any of this, but this is important for your everyday life. And it's often one of the first ingredients listed in soft drinks. This is the diet. Anybody else have a soft drink in here? No. Yeah. Yours is a diet, though. It won't be. Yours won't have high fructose corn syrup. That's what I drink too. Not that you can tell. Anyway, so yeah, it's ubiquitous. That's what it is. Here's how it works. You're probably thinking, what's corn have to do with this? This is how. So they take the corn. Corn has a lot of starch, and as you're going to learn later, the only thing starch is a bunch of glucose stringing together. So they break it up. So they have those individual glucoses. They do a little a chemical magic and convert that glucose to fructose, because if you can remember the honey picture that I showed you, they're very similar. It's just that carbon with a double bond is just in a slightly different place. And then there you go, then you have high fructose corn syrup. That's also a really good independent work topic. Not necessarily for grades, they're all equal as far as grades are concerned, but for your everyday life, you could look into that. Because everyone's talking about how bad high fructose corn syrup is. So why? Why is fructose so much worse than glucose? Or for that matter, when you talk about sugar, good grief. How many of you ever heard of something called, or we call it, Mexican Coke, Mexican Coca-Cola? Have you heard that? What have you heard about it?
Oh, like has more sugar in it.
Yeah, they from what I've heard, I haven't verified this. They use real sugar, they use cane sugar, and we don't. So again, it's curious to see what's the difference. Is there a difference in the health? Is there a difference in the flavor? Is there a difference in the bottom line of the company? Right? It must be much cheaper to do this, is my assumption. Otherwise, why would companies do it? It's all about saving the money, right? All right, so that's high fructose corn syrup. No questions about that. This is some other stuff, not in your textbook. This is from the old textbook, but I'm going to say it because this is relevant to your everyday life. We won't get any questions on this. But back in 2016, the average American consumed about 130 pounds of sugar a year. Think about that. Like imagine a sack, or however many sacks you would need to have 130 pounds per year. That's a lot, right? Mainly as sucrose and high fructose corn syrup. It's bad for you, among other reasons. It's a major cause of tooth decay and overconsumption. It increases the risk of type 2 diabetes and heart disease, and they're essentially empty calories. So again, if you want to, for independent work, you can look into this stuff. Other than what I've listed here, or instead of just taking my word for what I've listed here, look it up. Find another source that corroborates what I say or refutes it. So that's it for disaccharides. Any questions about disaccharides? Okay. Now then, this is Ward's time to answer correctly. But anybody's welcome to answer. So now that we're done talking about monosaccharides and disaccharides, what do you think the next thing we're going to talk about is?
Polysaccharides.
Polysaccharides, yes. I was curious to see if anybody would guess trisaccharides, because that would also be logical, but we don't do trisaccharides. It's 1, 2, or 2 and more, right? So a polysaccharide is anything that's more than 2 saccharides put together. Now, usually when people talk about carbs, in my opinion, when I hear people talk about carbs in regular everyday conversation, this is what they're talking about. Complex carbohydrates. And again, remember, I told you need to know the monomers and the polymers. So I've already told you the polymer of carbohydrates is a monosaccharide. And this is nice and easy. The polymer of a polysaccharide or of a carbohydrate is a polysaccharide. Ugh, that's a tongue twister. But that one's easy, right? It gets harder. This one, the names match. You've got a monosacharide, put a bunch of monosaccharides together, you get polysaccharides. Put 2 monosaccharides together, you get a disaccharide. This one's easy. It'll get a little bit harder later. Are there any questions so far? We're talking more about polysaccharides, but so far, are there any questions? So again, when people say carbs in everyday language, this is usually what they're talking about. Once again, if you download the PowerPoint, you can watch these things coming together in dehydration reactions. You can watch all these monomers linking together to form a polysaccharide. Now, once again, you need to know subcategories. I should have drawn this on the board, but again, big picture here. We're talking about the 4 categories of biological molecules, and the one we're talking about right now is called carbohydrates. And the carbohydrates were broken down into 3 subcategories, which is monosaccharides, disaccharides, and polysaccharides. Now we're talking about polysaccharides, and now I'm telling you polysaccharides is also subdivided. So here we go. The first one you need to know is starch, and you do need to know this. So unlike the disaccharides, where like you don't need to know about lactose and maltose, right? I told you didn't need to know that. But for polysaccharides, you do need to know these examples and the differences between them. So yes, the first one is starch, which are made up of a long string of glucose monomers. Of course, I'm not going to ask it that way, and I've already told you that, and I said it in a different way. The way I said it is polysaccharides are made up of monosaccharides, right? And that's the same thing this bullet point's saying. It's just saying it a different way. You do need to know this. What is starch used for? is used by plants to store energy. It's used for energy storage for plants. You need to know that. And again, most likely the question will be me explaining, giving you an example of something, and you recognizing it as starch. So if I say in that explanation or in that question, I say anything about plants using it to store energy, you should automatically think starch. Which makes sense, right? Because like I said earlier, our cells, even plant cells, need glucose to produce energy, right? That's our main currency form, or main energy form. So it makes sense if you need glucose to just string a bunch of them together. And then when you need them, just take one off that string. Right? Oh, I could use glucose. Let me take one off that string. Does that make sense? Almost like those candy necklaces. So if you like, all right, I'll have one of those pieces of candy, so you pull it off the string and eat it. Same thing here. I'm not necessarily going to ask you this. Actually, I'm probably not. I might use it in the example to help you, like, this thing is used by plants to store energy. You can find it in potatoes, grains, and stuff like that. And you'd be like, oh yeah, that's starch. But again, I'm not going to say, which of the three types of carbohydrates are found in potatoes and grains specifically. Here's what it looks like. So here's a microscope. It's kind of hard to see. This microscopic picture of a leaf, or excuse me, of a plant cell. You zoom in, you've got these little starch granules. And what these little starch granules are made up of is this. This is zigzag. You can see glucose, 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 so on and so forth. Excuse me, I want to make sure we're still recording here. Just thought of that. Hey, we are. It's a miracle. Okay, sorry. Anyway, yeah, so that's what starch looks like. I'm not going to ask you what starch looks like, but there you go. Just a bunch of glucose monomers bonded together in a zigzag fashion. Any questions about that? All right, so starch is used to store energy for animals. What do you think the next, never mind. I meant to say plants and I gave away the question. Glycogen is the next thing we're going to talk about. Starch is used to store energy for plants. Glycogen is used to store energy for animals. You need to know that too. The key word there is store energy, right? They're not necessarily getting their energy from these things, they're storing their energy. Because just like in plants, as you can see from this picture, just a long string of glucose monomers strung together, right? Yes, sir.
Are we talking like this is a fat cell?
Great question, and we can get into that later a little. We will get into that later, but no, these are stored differently. This is usually in your liver, and it's basically, again, the animal version of starch is what it is. It's just a bunch of glucose strung together, and when we need our energy, we break that off first. Now, if you're like me, and you have some stored fat, then yes, your body can break that down too. But that's a different process because that is actually a fat, and we'll talk about that soon. But it kind of does the same thing because we do break it down chemically, and that releases energy. So similar in that, but yeah. So yes, glycogen though is the primary way that we store energy for animals. It's stored mostly in the liver, like I said, and also your muscle cells, which makes sense. Your muscles need a lot of energy, as you might imagine. And again, and then this bullet point really should have been in the previous slide too. When we need energy, we break that down. We break off a little piece of glucose and use it, right? Just like the plants do. It's a long string of glucose. So any questions about that? All right. So again, in the test so far, if you had to distinguish between glycogen and starch, you should think, okay, starch is what plants use to store energy. Glycogen is what humans use to store energy. And by the process of elimination, I'm hoping that's pretty easy for you. Because I think most of us are familiar with, at least starch comes from plants, right? Even if you didn't know that was the primary source of energy, or how they store energy, how they store energy, you should at least already have that association with plants and starch. So then by process of elimination, you should think, okay, glycogen must be for animals. That make sense? All right, some other things you can think of for independent work are, all right, so I've talked about plants and animals, but what about everything else? What does bacteria use for energy? Depending on the bacteria. What do fungi use for energy, right? There's all these things you can look up for independent work. Any questions about this slide? All right, there's a third type of polysaccharide that I'm going to teach you about. And it is the most abundant compound on Earth. Any guesses what it might be? I'll give you a hint if I don't get any answers. Though you might not know this either. It's commonly referred to as fiber. All right, cellulose. So you do need to know this for the exam. This is the third type of polysaccharide, cellulose. Again, the most abundant organic compound on Earth. Not that I'm going to ask you that, but it is. I'm also not going to ask you exactly how it works like this. But basically, the reason it's the most abundant organic compound on Earth is because every single plant cell, this is what their walls are made up of, is this cellulose. And I mentioned this earlier, I don't remember in what context, but most of the stuff you eat from plants cannot be broken down because most of it is the cellulose, right? It cannot be digested by the enzymes produced by most animals. And that's actually why it's good for you. So when you eat fiber, you can't digest it, which common sense might say, well, that sounds bad, right? Don't we want to digest things? But the reason it's not or good for you, the reason it is good for you, is because you can't break it down. So you got this long string of long string of glucose that can't be broken off, so you can't digest it. There's no calories. So instead, it just goes through your system and cleans you out. It starts basically snagging stuff from here, all the way out. So that's why cellulose is good for you. That's why fiber is good for you. Back to people trying to trick you and trying to lie to you, or more importantly, try to scare you with the truth. There's this meme. I found this meme. What's in your fast food? First of all, let me go on the record and say, it is obviously my opinion. I should say obviously my opinion. Why would you say my opinion? It is my opinion that fast food is bad for you. You can find a lot of facts that back up that opinion. So I'm not defending fast food here, but this is a stupid meme. What's in your fast food? And I'm just going to focus on this one right here. Where'd it go? Number 3, wood, parentheses, cellulose. I mean, I can't vouch for every fast food, but even in this picture, you can see that Big Mac looking thing. And I'm expecting my paycheck to come in the mail from McDonald's. Look at that big, delicious Big Mac, right? No. Anyway, you can see the lettuce. That lettuce has a bunch of cellulose in it. As a matter of fact, other than water, that's mostly what it is. That's why lettuce is good for you. Not much nutritional value, but it's a lot of fiber. It cleans you out. But the way they're trying to scare you is saying that there's wood. There's wood in your fast food. And that's, not right. What they're doing is confusing words, because wood is indeed made of cellulose. That doesn't mean everything that has cellulose in it is wood. And that's how people try to trick you. And once again, I recommend you don't eat fast food. Experts agree it's unhealthy. So I'm not defending fast food. I'm just showing you information, or showing you examples of misinformation. Misinformation where they took the truth and tweaked it just a little bit. Any questions about that? All right, the next word for attendance will be cheeseburger. And once again, if you're watching the video, not if you're live streaming right now, but if you're watching the video, instead of sending me just the word cheeseburger, send me a picture of a cheeseburger, preferably your favorite cheeseburger. And I won't make the same beer joke, because I cannot accept extra credit for cheeseburgers. I would not accept a cheeseburger. Anyway, any questions about this? Let me show you this then really quickly. This is what cellulose looks like. And if you're a thinker and your memory's working, even though it's kind of early for a Friday, hopefully this looks familiar to you. Look at this. There's a long string of glucoses, right? But can anybody, not that I'm going to test you on this, but what would you say is the main difference between this picture, right? With that, the structure of that versus the starch and the glycogen that I showed you. Remember, the starch and the glycogen look very similar. This looks similar, but remarkably different than both of the others in a certain way. Can anybody tell? Good, it is straight, yes. And as I keep saying, same form. It has like mostly the same form, so mostly the same function. But these two, this one has a much different form than the other two. And it's straight, right? So that tells us, without even being chemists, that it obviously has a much different function. In this case, it does. Whatever it is about this straight line, whatever, chemically, whatever it is about that, most animal enzymes can't digest it. And I'll teach you what an enzyme is later. So let me just rephrase that. Most animal stomachs, we can't digest it just because it's in a straight line. There's something about that line chemically that makes it undigestible for most animals. Any questions about that? All right, and then there's one more to teach you. It's called chitin. This one's interesting because unlike any of the other ones, this one's a nitrogenous carbohydrate. So it's still obviously mostly made out of carbon, just like anything that we're talking about. But this one also has some nitrogen. And it has a lot of different functions, but I would say the main function is arthropod skeletons, exoskeletons. So the crunchiness of a spider, or when you bite into a good grasshopper for an appetizer, or crack a, I'm just kidding, I don't know if you would or not. That's actually a Katie did anyway. Or eating a crab, right? So anyway, not very important as far as the exam is concerned, but there you go. Any questions about what chitin is? Not much to say about that. Here's a table I made up. This is not in your textbook, so if you're studying, I think this is a good PowerPoint slide for studying because everything we just talked about is compressed into one nice little slide where you can compare and contrast everything, right? You talk about the monomers of starch, right? You can find where it's used. Same thing with the glycogen. You can compare all these things. And that's actually how the exam's going to be, right? You need to be able to compare and contrast. Or more specifically, I'll give you examples, and you need to recognize it as starch or glycogen or cellulose or chitin. So there's no need to memorize this whole form. But if I gave you anything from this form, you should recognize some of it and be like, oh yeah, he's describing glycogen, or he's describing chitin, whatever it may be. So, any questions about that slide? Yes.
I have a question about that slide specifically.
Okay.
A monomer is just one molecule?
One building block. One building block. And yes, for the purposes of this class, that building block is a molecule of sugar, right? A molecule of glucose or a molecule of fructose. So, yeah, we could say molecule. But again, as far as the exam is concerned, like whether you call it a molecule or a building block, it's just one part that gets put together with a bunch of parts to make a large part. So a pearl necklace, again, the pearl would be the monomer, the whole necklace would be the polymer. A train, every single train car would be a monomer, the whole train would be the polymer. Take that answer.
Yes, sir.
Awesome. Any other questions?
I've got a question.
Yeah.
When you say the starches and stuff are converted into energy, is there like a big flash or an explosion in your body?
That's a great question too. And with next module, we'll talk about how that happens. But to give you that answer, no.
Oh,
But I love that you asked that because once we talk about energy, there's different types of energy. There's heat energy, light energy, sound energy. And when this happens, energy is in fact released. And once we get there, I can teach you how. But it's not light. But some things do light up. Not in humans, but there are some cells that do light up. And it is by breaking something down and releasing energy. So that's a great question. So if you can marinate on it for a couple of weeks and we'll come back to it.
okay.
And then again, there's some pictures of it. So again, you can see how like starch looks like that. Glycogen looks just like starch, except it has little branches. It branches off, right? So once again, similar form, similar function. Storing energy for plants, storing energy from animals. Then you have cellulose that looks similar in that it's a bunch of glucose that's strung together, but different because they're all straight. So again, different form, different function. Any questions about that? We can jump into the next one. The next one's very easy. Lipids. So again, big picture. We're talking about biological molecules. We've already talked about carbs. The next big one we're talking about are lipids. And one thing I didn't tell you about carbs, because I wanted to have it in the proper context, is what I'm about to tell you now. Carbs are what we call hydrophilic. So that's another thing you need to know about carbs. They are water-loving, hydrophilic. This is why sugar dissolves when you put it in water. Because it's attracted, right? It's a polar molecule, just like the water. So it's hydrophilic. So that being said, now that I'm putting things in context, What do you think I'm about to say about lipids? If carbs are hydrophilic, what do you think I might say about lipids?
I don't know the difference.
They are the opposite. So they are hydrophobic. So since lipids are hydrophobic, will they dissolve in water? No, they don't mix with water. Since carbs are polar and hydrophilic and water is polar, what do you think lipids are? Polar or non-polar? Non-polar, exactly, because they don't mix. And as far as we're concerned, that's why they don't mix. Because non-polar and polar don't mix. Now, granted, I'm sure you've seen salad dressing that has oil and vinegar in it. Doesn't always look like. If you were to get some oil and vinegar based salad dressing, what would you do before you used it? Yeah, you shake it up, right? Because it's separated. And when you shake it, it is mixed as far as eating is concerned, but at the chemical level, it's not mixed. What you've done is called something that you don't need to know this for the exam, but it's called emulsify. So when you shake it, what's happening is you just get little tiny bubbles of the oil that's suspended in the liquid, but they're not chemically mixed. They're still distinct things. Anyway, yeah. So yeah, oil is a type of lipid. We're going to talk more about lipids, so you don't necessarily need to know that oil is a lipid or the vinegar is a water, but there you go. So let's talk about how lipids are different from the other four, right? Because remember, it's going to be a lot of comparing and contrasting on the exam. How are lipids different than proteins, the nucleic acids, and carbohydrates? First of all, they're not huge macromolecules. So think about starch, right? It's a long molecule of carbohydrates. DNA, which you're going to learn about later, that's a long string of molecules that you're also going to learn about later. Oh, also, back to Bree's point or question. When we talk about nucleic acids, those monomers are not always one molecule. Sometimes that one, actually they're not. Those monomers are built up of a few molecules put together. So this is why I like to use the word building blocks. Anyway, another thing that makes them different is they're not repeating monomers. So lipids are built from different pieces, but they're not repeating pieces, right? Starch is just glucose, right? It's just a bunch of glucoses. Lipids, no, they're not repeating. They do have different parts. You can break them down into their parts, but those are different parts. So technically, they don't have monomers and polymers. So remember that for the exam. This is the one category that doesn't have technically monomers and polymers. So let's talk about the first one. When someone says fat, this is probably what you're thinking of, I would assume. A typical fat is also called a triglyceride, and you need to know that. So Kestersen's question earlier about your fat cells, that's this. Those are triglycerides. They're made up of a glycerol molecule that has 3 fatty acids attached to them. I'll show you a picture of it. And once again, if you're studying this and reading this and thinking, oh my God, that's a lot of information, just remember, it's a multiple choice question for a 100 level class. So I'm not going to say, what are triglycerides made up of, right? But you might get a question where I'm like, name this molecule. It's made up of a glycerol molecule with 3 fatty acids. And it has twice the energy of carbs, right? All this stuff I'll use as a hint, and you'll have to guess that it's fats. But it's not going to go the other way around when I say explain what a fat is. So don't stress. Everything's okay. And like he was asking, once again, this last bullet point right here, stored in adipose cells. So that's what fat cells are. So I have a lot of extra triglycerides. Because all I'm doing is grading. Past a month. Anyway, any questions about that side? So when these things come together, this is how they're built. Like I said, triglyceride is made up of a glycerol molecule and 3 fatty acids. They all come together to make a big E-looking molecule, like a capital case E. Guess what kind of reaction brings these things together? Between the two of them, if it's bringing molecules together, which one is it? Well, you got at least one of the 2 correct, right? It's actually dehydration. But I'm glad you guessed that. At least you know the 2 that we're talking about. Yeah, it's actually dehydration. Remember, if you're bringing it together, it's dehydration. Anyway, and that's what it looks like, right? So you can see, here's the glycerol, here's this fatty acid attaching to it. Of course, you're squeezing out a water molecule, which is why we call it a dehydration reaction. And here's one that has 3 fatty acids. One thing I will point out that's a little bit less important for the exam, but important for you to understand what I'm going to teach you next, is that this is the beginning of the weekend, so we are done, and I will see you on Monday. Remember, I have extra long office hours today until 12, so if you're turning stuff in, like your lab that's due today, or your pre-lab that's due today, come to me, I'm here to help. Online is best, but if you want to meet in person, I will be in my office at least until noon. Have a great weekend. Yes.
Do you have like do you usually see like the replies?
Always, that's why I do, yeah, and just a little bit of information, so you know what's going on. Okay, the reason I do things this way.
Because I saw one of them, I sent
Noah, did you have any questions?